So this energy diagram is a slightly different take on the one that we just discussed. And in this case, I'm just going to simplify reactants and products by getting rid of X, Y, and Z and just say reactant and product. And so again, what we can do is if we're doing a reaction and we have this starting position for the reactants and we have this end product or in position for the products, we can compare and contrast the energy levels. And it seems pretty intuitive that the energy of the reactants is higher than the energy for the products. And so what this means is that the reactants are less stable than the products. And if we're thinking about thermodynamics, and we wanted to ask the question, how much products will we have and how much reactants will we have given an infinite amount of time, we can then say which would be more favored at the end of the day. Would we have more products out of the reaction, or would we get more reactants just kind of sitting there not reacting? And in this specific scenario, because the products are more stable, eventually we're going to be able to go over this energy hump, this transition state, and we're going to be able to form more products than reactants given enough time. And then if we consider the equilibrium of this reaction, or the equilibrium constant, if we think back to how we defined the equilibrium constant before, we said that the equilibrium constant is always products over reactants. And so in this case, let's just make up some random numbers. In this case, what we could say is that our equilibrium constant would be 100, or if we want it to be, super duper vague, we could say that the equilibrium constant is going to be greater than 1. So what we can say is that if the equilibrium constant is greater than 1, we can then say that the products are going to be favored at equilibrium. So now in this opposite case, we can also imagine a scenario where the products actually have, instead of a lower energy than the reactants, higher energy. And so again, if we wanted to talk about the thermodynamics, how much is going to be formed given an infinite amount of time, it's obvious that the products have a higher energy than the reactants. And so that means that the products aren't going to be as favored as the reactants, and must mean that we're going to have more reactants than products given this reaction condition. So randomly putting in some numbers, again, let's just say we have 100 reactants for every 1 product. And so we could say then that the KEQ is actually going to be less than 1 in this case. And so the generalized feature we could say now is if KEQ is less than 1, the products are no longer favored. It's actually going to end up being that the reactants are going to be favored in this case.